All right, so I've got to do a large but simple project. I've got some... All right, so the foul poles are really simple. We just need to bend that loop and fill it in with some expanded metal, and hopefully we can get that done pretty quick. All right, so we're gonna do a bend. I want to explain how to set your tube in the bender to get it to line up where you want it to. On my plan right here, I know where the beginning of my bend and the end of my bend is in my tubing. All right, and I also know that the beginning of my bend on a 6-inch die is actually 6 inches from where the beginning of my bend is. So I double checked for every degree you bend in a 6-inch die, it results in 0.104 of an inch. So I times that by 90, get 90-degree bend, and I had 9.36. That's how much was in the bend. So because I knew it was after my bend, this is in my bend, and that's after my bend on this side. I added it all up, it all came out to the overall length, so I knew I was right. Now this block, this is the block you're going to use in this bender, and this holds the tubing in place while these big discs spin around. Okay, and on the inside, that's your 6 inches. So here's your center of your die, 6 inches to here, and that's where is going to offset and start bending. And the way this bender works is it actually pulls the tubing through the die and around, so it's like a draw, right? It's going to draw the tubing through and bend it around. So I know where I want my bend to start, essentially, or I guess you could say end, and I'm going to then wrap it until it hits 90 degrees, and then I will stop and take it out. So in class or online, we can talk about what these offsets are. This is a 6-inch die, but they also come in 4.5 and 3.5 and 2.5, and but essentially the diameter is the same on a 6-inch, whether it's round or square, and that circumference, the center line radius, is also the same on that diameter. So how much material you use in a bend, that's always going to be the same on a 6-inch, 4.5, a 3.5. So you can look those informations up, or when we're in class and we're starting to bend it, we will calculate how much material you need to use through here. It's nice when you have a CAD system because it'll automatically tell you the overall length, but maybe where we put the block to pin the tubing, that might be different per bender. You know, maybe if it's a rogue bender or another one, sometimes you actually have the exact spot marked out on the die with the 0, so you know exactly where 0 is, and you can just bend from there. But the way this one works, 6-inch offset. So I know that to get my die or my tubing to start bending where I want it to, it was 3 5/8 in to the front side, which put it at 5 1/8 on the back side, and that was 6 inches from the beginning of my bend, if that makes any sense. So I'm going to stick this guy back on here real quick. Now, because I have a straight piece going out that way, I don't need to angle it. It's just round, and we're going to bend. So I'm going to go 3 5/8. I have a wrench. We've all had troubles. Okay, so we're going to then tighten down our jack. That way we have hydraulic pressure. While I bend this, my air compressor is going to kick on. It's going to be really loud, so we're not going to be able to hear each other, but you'll see it. It'll bend. I did make a little mark because I haven't painted this, and I'm going to do a bunch of stuff, but I did make a little Sharpie mark at where my 90 degree is, and then I put this nice little piece of filler rod they've bent and that screw in here. So I'm just going to bend this all the way around until it gets to that mark, and then we'll be done. All right, you may have noticed, you can maybe see that mark right there. I bend past that mark because the steel is always going to have some memory left into it, even though we're deforming it essentially, and it's called spring back. And so you want to make sure you bend it enough past the bend where you want it to spring back and stop right at it. So I went just a few degrees out, and that's why. So I'm going to take my square, take the short end in there. Get that nice and plumb against there. Should be plumb against this block because it should be square, but also you can see, you can look for a parallel line up down to there. Okay, so same thing on this side. Now before I clamp that down, I need to make sure that this side is level over here. So I'm just making sure that this torpedo level right here is exactly plumb this way. Now there's a lot of different levels you can get, digital ones, really accurate ones. This one will work too for simple stuff. If you're gonna do complicated offset compound bends, you're gonna wanna get one of those digital magnet ones that you can just pop on there, you can reset it, you can calibrate it. Those ones are really nice, but they also come with a price tag. That was pretty basic bending right there. You can't get much simpler than that. 2 90s on the end of a piece. You just need to make sure that those are lined up, right? Because if your pieces are that way, they don't end up in the same plane. Since these are getting welded on a single stick of pipe, they need to line up. And so it's pretty important to do that leveling there. Make sure the offsets so it's the same distance all the way down, but really you can't get better than that. All right, so after a long night, foul poles are finally done. Really not that much to them, but some calculations. You need to make sure that they're the right height on the flags so that you can clear the fence and get them buried into the ground. A few things like that, but bending super easy, I guess. Cutting out the expanded metal might have been the hardest part, but yep, they're all done. So I think we're done.